Today's video, we are going to be talking about right triangle trigonometry as a way to refresh our brains and what we learned in 9th grade geometry. Let's go ahead and jump in. So just a quick overview in case we forgot what trigonometry is. Trigonometry is all about right triangle, where one of the internal angles is 90 degrees. Now, this might sound familiar from when we were doing Pythagorean theorem. Both Pythagorean theorem and trigonometry are for right triangles. And trigonometry is a system that helps us find the missing sides of a triangle. Now, you might be thinking like, Miss, we just learned Pythagorean theorem. Isn't that to find a missing side? Yes, it is. But trigonometry helps us find a missing side whenever we only know an angle and one other side. Whereas Pythagorean theorem, we can only use that if we know the length of two sides. So trigonometry is just another system that helps us find a missing side in case we're given other information. So if another angle that we know is often labeled theta, which is this symbol right here, theta, and the three sides are as follows. The side across from the right angle is the hypotenuse. The side that is opposite of theta is labeled opposite. And then the side that is adjacent, or also known as next to theta, is called adjacent. So you can see how these are labeled right here. We have our hypotenuse that's across from the right angle. We have opposite over here, which as we can see is the farthest or opposite away from theta, or angle theta. And then we have the adjacent side, which is the side that's right next to theta. That's not the hypotenuse. Now, opposite and adjacent, just kind of like the legs with Pythagorean theorem, they will change depending on where theta is. So as we can see right here, theta is in the bottom corner. But if I drew another triangle, and if I put theta in the top corner over here, well, then opposite would be down here because that side is opposite, and then adjacent would be over here. So again, it just depends on where theta is, and the more you practice this, the more you'll get the hang of it. All right, so we're talking about trigonometry. We're talking about sine, cosine, and tangent. There are three basic functions in trigonometry, each of which is one side of the right, the one side of the right angled triangle divided by another. So the functions are sine, cosine, and tangent, which are abbreviated to sin, cos, and tan. And we could see what their ratios are right here. When I say ratios, I just mean the fractions that they make. So we can see that sine theta is equal to opposite over adjacent. Cosine theta is equal to adjacent over hypotenuse. And tangent theta is equal to opposite over adjacent. Did I say that wrong? Sine theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. And tangent theta is equal to opposite over adjacent. Now, this might look familiar. This abbreviation, SOHCAHTOA. SOHCAHTOA, hopefully that sounds familiar from your freshman year in geometry. That is where the ratios come from. S standing for sine, and then OH being the ratio, opposite over hypotenuse. C standing for cosine, and then AH standing for adjacent over hypotenuse. T standing for tangent, and then the ratio being opposite over adjacent. So let's see what this looks like in practice. So if we have this triangle, given triangle ABC, find AC. So we have our question mark. This is the reason why we have trigonometry, is because if I'm just looking at this triangle, I can't use Pythagorean theorem to find it, because in Pythagorean theorem, I have to have two sides so that everything is plugged in. Over here, I only have one side. So I'm going to label, just like I do in Pythagorean theorem. First step is label what my hypotenuse, H for hypotenuse, what my adjacent is, and what my opposite is. So that is what I'm going to label H, A, and O. So first thing I'm always going to label is my hypotenuse, because for me, that's just the easiest one to identify. It's the one that's opposite the right angle. And then right here, this 50, that is our theta. That is our given angle. This right here, this guy, that is theta. So according to where theta is, I know that opposite is going to be the side that is furthest away from it, the side that's all the way over here. So that's going to be my opposite side. I'm going to label that as O. And then my adjacent side will be the one that's left over. Perfect. So I always label hypotenuse opposite adjacent, because I just find that easiest. All right, let's switch colors here. So now that I have everything labeled, I'm going to use SOHCAHTOA to help me out. And actually what I'm going to do is erase this part right here because I feel like all these letters might get a little confusing. If it'll let me erase. No? Maybe. Interesting. Okay. Guess I'm not erasing. Oh, there we go. Okay. All right. So I'm going to use SOHCAHTOA. SOHCAHTOA to help me figure out what ratio I'm going to use. So first step, label. Second step, use SOHCAHTOA to pick your ratio. So I can see right here that I have H, right? H has been given to me. H is 6. And I'm looking for O. So those are the two sides that I need, which kind of means that A is like irrelevant. I don't really need it. It doesn't tell me anything. So going into SOHCAHTOA, I'm asking myself, what part of SOHCAHTOA has both an O and an H? And we can see right here that is sine. Cosine has A and H, which again, I don't need the A side, and TOA has O and A, and I don't need the A again, so none of those work. So I'm going to use my sine ratio. So in order to use my sine ratio, I'm going to say sine theta is equal to O over H. And now that I know what formula I'm using, I'm going to use my sine formula. I'm just going to plug in. I've got sine, and then my theta is 50 is equal to O in this case is unknown. So I'm just going to put X over H is 6. So I'm going to put 6. Boom. And now we just have like a one-step algebra problem that we need to figure out. Sine 50, you can put that into your calculator and get it as a number, but I'm going to just leave it for now because usually those end up as decimals. So right now I have X being divided by 6. So I'm going to go ahead and do the inverse operation of that. I'm going to multiply by 6 so that those cancel. And then same thing on this side, I'm going to multiply by 6. So X will be equal to 6 times sine 50. And I end up with 4.6. And if you're wondering how I got sine 50, I just put it into my calculator. So if you see right here, I literally typed into my calculator 6 times, and then I hit the sine button, which is located right here, sine 50, and then I close the parentheses. Boom. And that's how I got it. 4.6. If you're not getting 4.6, if you're getting a vastly different answer, it probably means that you're not in degree mode. So make sure that you hit mode. It's right up here by second. And on the third line down, switch it from radian to degrees. And if you have questions about that, just call me over to your desk.